So this is 1.6 piecewise functions to what we did yesterday, the restricted domain problems. All we're going to do now is put more than one on the same graph. So it's the exact same idea, it's just you're going to do a couple of them on the same graph, or maybe even three on the same graph. Okay, so the directions are going to be this. It's going to say graph and show significant points. And for the first three here, we're also going to find the domain and the range. I think on part of it, just read it. You don't have to find the domain and the range every time. Read the directions. I think the first page on your homework, you have to find the domain and the range, and then after that you don't. Okay. So we'll practice that a little bit more, because these are a little bit different. The domain problems are going to be a little bit different. So, okay, are we ready? You guys with me? Number one, this is what a piecewise looks like. They'll have the function over here, and they'll have an equal sign, and then they'll set up this brace like this, and then they're going to list the two or three restricted domain problems. So the first thing we're going to graph is this graph if x is less than -1. Okay, so that restricted domain problem, and then on the same graph we're going to put this graph, 3x minus 1, if x is greater than or equal to -1. Okay, so we're going to put two of these restricted domains on the exact same graph. Now, in the worksheet that you did yesterday, I loved the way they set up every time f of, and you had to find that. I want you to do that here. It gets a little bit tricky because you're going to do f of -1 twice for two different functions, okay? But I want you to do it. And so what I'm going to do over here, you can either make a little t-chart if you like, or you can list it as coordinates. Do you guys have a preference to list it as coordinates or to make a t-chart? Do you care? Okay, then I'm just going to put coordinates, and then we'll write above it if it's open or closed. Okay, so if this is -1, you absolutely need to know what's happening at -1. So what I'm going to do is I'm going to plug -1 in here. Well, if there is no x, we did one like this yesterday or Wednesday. Do you remember what the answer was? It's 3. Yeah, the answer to this is 3. Okay, now, since there's no equal sign here, I'm going to make this open. That's going to be one of the first things I plot. Okay? Down here, I'm going to do the same thing. I'm just going to do these right off the bat. I'm going to plug in this -1 here, and I'm going to get 3 times -1. Do that with me. What is that? -3 minus 1, -4. And this one, because there is an equal sign, I'm going to make closed. And again, that's going to be some of the first things I graph. Now you're going to have a grid, which will help, but for now, since we don't have it, we're going to set up an x and a y axis. And I'm kind of looking at where I am. I'm going to put the x-axis in the middle. And I'm going to go to -1, 3, and put an open circle, and -1, -4, and put a closed dot. Okay? So one of those points goes with one of the graphs, one of my restricted domain graphs, and the other will go with the other. Okay? And we'll just have to keep track of which one went with which. Okay, so now we're going to do the first part. We're going to pretend like this isn't even here. And let's do this. This is like what we did yesterday. We're going to graph f of x equals 3 just when x is less than -1. Okay, well, first of all, you got to know what that graph is. F of x equals 3, that's the same as y equals 3, right? What's that look like? Horizontal line, right? Horizontal line up at 3. Now, I could, theoretically, I'm going to just lightly do this, I could graph the whole thing, but we don't want the whole thing. We just want the part when the x values are less than -1. Okay, so here's the point that we're working from. It's either everything to the left or everything to the right. What would be when x is less than -1? To the left. Okay, so we're going to sketch, whoa, pretend like that's straight. Okay, do a horizontal line going that way. That's that first restricted domain part. That's the first piece of this piecewise function. Okay, now we're going to go to the second piece. And now we're down here. We're at this point, right? Okay. This, how would you describe this graph? Quadratic, linear, absolute value, exponential, what is it? Linear, right? That's been shifted down 1. Okay, so the question is, typically we would have started right here, down 1. That would have put us right here, but will that be part of this graph? Will that point right there fall in this graph? Well, the x value right there is 0. Is 0 bigger than -1? Yeah. Okay, so we want this part of the graph that's to the right of this. This is to the right of it, so I'm going to include it. Then the next thing we would have done is we would have looked at the slope, which was 3. Look, from here, if you go up 3 over 1, you're right there at that point, that downshift. So I'm just going to go up 3 again over 1, okay? And then you're going to start at -1. We don't want to go to the left of -1. We want to go to the right, which is to go up this way. Don't do the down part, okay? The down part here would have been the whole line. We don't want the whole line. We want a piece of it. We want to start from -1 and go right. Okay? That's it. That's all we're doing today. So just putting a couple of them together. All right. The domain, you guys, the x values. How far left does this graph go? Negative infinity. Okay, so we're going to go negative infinity. We read left to right. So we'll start at negative infinity. And then we're going to come, and now we kind of have a little trouble spot right there when the x coordinate is -1. But look, down here there is a point that goes with that -1. That point wins. Okay? So -1's okay. We've got a value for it. And then it's going to keep going how far to the right? All the way to infinity, right? So the domain is all reals. Every value of x has a corresponding function value. Okay, a place where it is solid. This is kind of the only tricky spot, but it has a place where it's solid. We include it then. Okay? All right, for the range, I want my lowest y. Now, there definitely is a lowest y here, right? Down here at -4, and it hits it. Okay? But then look at this, just keeps going up and up and up and up forever. This guy right here is going to take everything, right? So it's going to go all the way up to infinity. Okay, let's do another one. All right, set up your function. We're going to again do a two-piece piecewise. For the top piece, I want you to graph x plus 2 quantity squared if x is less than 1. And for the second piece, I want you to graph the absolute value of x plus 1 if x is greater than or equal to 1. Okay, so we're doing two restricted domain graphs on the same graph again. The first one, we're going to do this parabola, and we're going to graph this part of it when x is less than 1. A significant point is what's happening at 1. So plug that in first here. Okay, so when I plug it in, 1 plus 2 squared, 1, 9, is it going to be open or closed? Open, right? So I'm going to make note of that. That's one of the first things I'm going to sketch. Okay, then I'm going to plug 1 in here. 1 plus 1, absolute value 2, right? Open or closed? Closed. Okay, so these are two of the significant points. There's others. We're going to make sure we get our vertices, right, for both of these. All right, 1, 9. Wow. Okay, so as I sketch it, I'm going to drop my x-axis way down because I need to go all the way up to 9. So at 1, 9, after you figure out where that is, put an open dot, and at 1, 2, put a closed dot. So the top graph here is going to go through 1, 9. I mean, it's going to contain 1, 9, okay, or extend out from it somehow. The second graph is going to hit the 1, 2, and we're going to figure out it's going to be one side or the other. All right, so let's go to this top graph. Are we ready? You guys with me? Okay, on this top graph, I know that this is going to be the point. Now, since I'm doing everything less than 1, I want this graph that's to the left of that point. Okay, so now, is the vertex going to be there? Are we going to be able to see that? How is this parabola shifted? 2 to the left. Okay, so if I shifted it 2 to the left, is that point right there to the left of this one? Yeah. Okay, so I'm going to include it. So I'm going to put that dot there. That's a significant point. Our vertex is a significant point. And then what we did to graph this is we went up a over 1, right? Well, if I go up a over 1 in both directions, both of those are also to the left of this point up here, okay, to the left of 1. So I'm going to have a big part of this parabola, aren't I? So this is going to come up and hit this guy up here, and then on this side it's going to keep going on and on forever, so I'm going to put an arrow to show that that keeps going and it doesn't stop. Okay, so this is that parabola for all values less than 1. X is less than 1. Okay, then we're going to come over here and graph this absolute value. Now let's see if we'll see the vertex on this. Okay, and it should hit this point. Okay, which way is this vertex shifted? Left 1. So the vertex would be right here. Now the question is that in this restricted domain? Okay, how would you describe this x is greater than or equal to 1 from this point? Would that be to the left of 1 or to the right of 1? To the right. This is not to the right, so I'm not going to plot that point. Okay, but I'm going to pretend like it's there. Pretend like if it was right here. From here I would have done the slope, right? I would have gone up 1 over 1. That point's not to the right yet. Up 1 over 1. Now I'm on it, and then from here I'm just going to keep going. Up 1 over 1. Maybe do one more of those. Up 1 over 1. Okay, so the vertex would have been down here. This part's not in the graph, so I'm not going to include it, but I'm going to pick it up right here and shoo, continue it on. Almost just looks like part of a line, which if you cut off the vertex of your absolute value, it's just going to look like you have part of a line. Okay, a little trickier because we can't see the vertex. You okay with that one? Let's write the domain. What x values? How far to the left does it go? Is there a stopping point here? No, so it keeps going, negative infinity. And then I do have a, as I come along here, this is a critical point, but look, it's got a solid dot right here, so that solid dot wins. And then it just keeps going to the right, so the domain's all reals. How about my range? Is there a lowest y? What is it? 0, and it is going to hit it, right? So I'm going to put a bracket. And then from here, this just keeps going up and up and up, so all the way to infinity. Okay. Or have you do a sandwich? Okay, yeah. All right, number 3. Okay, let's try this one. F of x equals the brace. First restricted domain problem is going to be 2 to the x plus 1, and that is if x is greater than negative 2. Negative 2 times the absolute value of x plus 3 minus 1, and this is going to be for values less than or equal to negative 2. Okay? So again, the direction is going to be sketch the graph, find significant points. And so again, what's happening at negative 2 is significant for both of these. So I'm first going to plug in negative 2 here. When I do that, I get 2 to the negative 2 plus 1. What's that? What's negative 2 plus 1? So 2 to the negative 1 is what? That's a half. Okay, that was the point when I plugged in negative 2. So I'm going to have the point negative 2, 1/2. Am I going to make it open or closed? Open, right? Okay, here I'm going to plug in negative 2. I want you to go ahead and do it, and I want the partner on the left to tell the partner on the right what they get when they plug in negative 2. Okay, so go ahead and tell your partner on the right what you got. Should be telling your partner on the right what you got. Left partner, you should be talking. All right, right partner. Who thinks their partner got it right? What'd your partner say? Negative 3. Anybody else get that for an answer? Yes? Negative 3. Okay. Open or closed? Closed. Right. Okay. Good. Set up an x and y axis. Plot those points. Negative 2 1/2. Open. And negative 2, negative 3, closed. Okay, these are dividing points. We're going to graph everything to the left of one of them, and we're going to graph everything to the right of the other. Okay, so we're going to figure out which it is. Yes. How do we get negative 3? Okay, do you guys not agree with the answer? If you plug in negative 2 here, negative 2 plus 3 is 1, right? Absolute value of 1 is still 1. Times negative 2 would be negative 2, and then minus 1 would be negative 3. Thank you for asking that question. Appreciate you doing that. Okay, are we ready to sketch this? Everybody got this set up? All right, so this negative 2/2 right here, this is part of this graph, okay? And it's going to be either where we start or it's going to be where we stop. It's based on this. If x is greater than negative 2, are we graphing everything to the left of this or everything to the right? If x is greater than negative 2. We're going to go to the right, yeah? Okay, so now let's see, would our starting point be in this, would it be to the right of this point? Okay, what kind of shift is this? If it's x plus 1 up in the power left, where does exponential usually start? 0, 1. So if I go left 1, yeah, you know what, that's there, so I'm going to make that solid, put that there. And from there, to find the next point, we looked at the base, right? And if it's 2, we went up 1 over 1, right? So I'm going to go up 1 over 1. That's the next point. I want everything bigger than negative 2. So negative 2 is where I'm starting. And then I'm going to just shoot that up and draw an arrow because it's going to keep on going up and right forever. Okay, so that means this must be down here. It must be the part of the graph to the left of this point. Okay? So we need to know, is the vertex here part of that? How is this shifted? Left 3. Down 1. So 1, 2, 3, down 1. Would you describe this point as being to the left of that? Yes, it is. Okay, so that is going to be a point on our graph. And it looks to me like then I want to stop at this point, but I want all the rest of it. Okay? This has a slope of negative 2, which means I would have gone down 2 over 1. Sure enough, I'm going to hit it. You should every time. You should hit that point. If you plugged it in right, you should. So this is going to be right here, but that's not all. What else do I need? Am I going to keep going up this way? No, I'm going to go down 2 over 1 the other way, right? And this will continue on and on and on. Do you see why we put an arrow here but not here? Got the difference between those? Okay, because this says just graph everything to the left of negative 2. Stop when x is negative 2. Do you have a question? Okay, domain real quick. If you look at your x values as you come across, it's all of them. All reals. Remember what I said? When in doubt, I'd choose all reals. That would be my guess. Now, all reals, you guys, some of you got this backwards, like I said on the quiz. Make sure it's negative infinity to positive infinity. It doesn't make any sense to go the other way around. Okay, it's smallest to biggest. Negative will always come first. Okay, range. My lowest y, it looks like this is going down to negative infinity, right? So my lowest y would be negative infinity. Is there a place where it stops, where there's a gap? Yeah, there is, right here, right? There's no y values in between here, so we need to stop it right there. What's the y value there? Negative 1. Does it hit it? Okay, yeah, so we're going to put a bracket there, and then we're going to set up the little union thing, right? Where does it pick it up again? What was the y value right here? We found that up here was a half, right? So it's going to pick it up at a half. Does it hit a half? It's got an open circle, right? So we put a parentheses. Okay, and then where does it stop? It doesn't, right? Keeps going on to infinity. Any questions? Okay. 1, I'm pretty confident with this. 2, I'm mostly confident. 3, I'm mostly not confident. 4, I'm definitely not confident with this. Can you tell me where you're at, please? 1 to 4. Tell me where you're at. Okay, so we have a few 3s, mostly 1s and 2s. So what we're going to do is we'll pick one off the homework to do another example of that. I'd like to show you the other kind of problem that you're going to have. Okay, so for this next one, we're not going to find the domain and the range. I want you just to find the given values. Sorry, we'll do it in the homework in just a second. Okay. So we'll come back and we'll make sure we do one of those just to make all our 3s at least 2s. Okay, so given this, this is number 4. Given that f of x equals the quantity x minus 1 squared if x is greater than 0, and 1 if negative 3 is less than or equal to x is less than 0. I want to make sure we do a graph. I'm not going to take the time to graph this one right now, but I want to make sure we do one of those on the homework. Okay, so help me remember that when we do the homework problem. Okay, I just want you to find these values. I want you to tell me what f of 3 is. I want you to tell me what f of 1 is, and I want you to tell me what f of negative 1 is. Okay? So you can do this without graphing it. It's helpful actually if you have the graph, you could look at the graph and see what's the y value at those places. Okay? But you can do this without. Okay, so watch this, you guys. You ready? This is how you do it. If you're asked to find f of 3, 3 is in the spot of x, right? This is usually f of x. It's in the spot of x. Okay, what you would need to look at here, where does 3 fall? Where does that number 3 fall? Is it greater than 0 or is it between negative 3 and 0? It's greater than 0. That's the equation you want to plug it into then. Okay, so you're going to take 3 and plug it in here. So it would be 3 minus 1 quantity squared. What's 3 minus 1 squared? That's the answer. Pretty easy, right? Okay, now let's do 1. So again, this is the spot of x, so you're going to look where the x restriction is. Where does 1 fall? Is it greater than 0 or is it between negative 3 and 0? Greater than 0, so that's where you're going to plug it in. This would be 1 minus 1 squared. Answer? One minus 1, 0 squared would be 0, right? Okay. Are we okay? It's a trick question. Yeah, 0 squared, 0 times 0 is just 0. Okay, now negative 1. Is it greater than 0 or is it between negative 3 and 0? It's here, right? Okay, now if there's nothing, no x to plug it into, what's the answer? It's 1. Yeah. Okay. What if I ask for f of negative 4? What do you think the answer to that would be? Because negative 4 is not bigger than 0, and it's not between negative 3 and 0. Okay. You can either write does not exist, which is DNE, okay, or you can put the empty set. I'll take either one. Okay. Let's do one more of that. Given this function, x squared minus 4, if x is less than or equal to 0, this one's going to be a 3-piece one. 3, if 0 is less than x is less than or equal to 2, 2 to the x minus 1 minus 5 if x is greater than 2. That's given. Okay, and we're going to find the following. I'm out of room, so I'm going to kind of slide it over. If you can just keep going straight down like we did above, do that. Okay. I first want you to find f of negative 2. So you're going to look at that negative 2 and you're going to figure out which one of these contains negative 2. Would you say it's the first, the second, or the third? Where is negative 2? Up here, right? Okay, so I'm going to plug in negative 2. Now you guys, when I take that negative 2, I take it in parentheses, and I put it in parentheses here. It's negative 2 squared, because that matters, right? If that negative is in the parentheses or not, that matters. Minus 4. So what's negative 2 squared? Positive 4, right? 4 minus 4? 0. Okay. I would like for you to plug in 0. See if you can figure out which one to do, plug it into, and this time I want the partner on the right to tell partner on the left what you get. What do you think it is? Okay, anybody think their partner got it right? What did your partner get for an answer, Carrington? Negative 4. Negative what?
Negative 4.
Negative 4. Anybody else get that for an answer? Yeah. Okay, because which equation did she plug it into? The top one, right? 0 minus 4, negative 4, yeah. Okay, question going back to this, why is this 0? Okay, do you see that we took negative 2 and we plugged it into this? You're okay with that? When you take negative 2 and you square it, negative 2 times negative 2 is positive 4. and then so it was 4 minus 4. Okay. All right, one more on this. I want you to find f of 2. F of 2. So go ahead and do it, and then switch whoever answered last time. Who did I ever answer last time? Okay, left partner. Tell your right partner what you got. Okay, who thinks their partner got it right? What'd your partner say, Melanie?
3. I got it.
They said 3. Okay, so which equation did he plug it into? The second one, right? You're going to look for where the equal sign is. There's nothing to plug into, so it's just 3 CG.